Okay, so I think we can start now. Okay. So hello everyone, welcome back and welcome if you are new to our weekly DTT. Thank you for joining us today, and this is our DTT week 4. So actually week 3. During the past maybe 2 sessions, we have explored Huawei Cloud Fundamentals and covered Huawei Cloud Computing and Storage Services. And in this session, we are going to cover Huawei Cloud Network Services. Then we are going to introduce Huawei Cloud KooLabs and also conduct a hands-on lab to practice what we have learned. So you guessed it right, with our global expert, Zainab Kujur. So hi Zainab.
Hi, Kristen. Thank you for introducing me and inviting me. I'm happy to be with you all in this third session of Huawei Cloud Services. Today, I will cover network services, and after I cover network services, we will hold a Kahoot, and then I will do a hands-on lab. I will open the Huawei Cloud console, and then I will create topology, and after it, we will hold another network session. So let me start by sharing my screen. So this is the second week of Huawei Cloud Fundamentals. Last week, we covered compute and storage. And like I said, this week is for networking. Again, I will start by introducing myself. I'm Zainab Kujur. I work as a cloud expert at Huawei Cloud. So today we will start with VPC, then continue with EIP, ELB, VPN, NAT gateway, and then the other services. So let's start with what a network is. A network is a system that connects multiple computers or other devices together so they can communicate and share resources with each other. And, when we think about internet, it's just a network, wide network. It's just some servers connected to each other, serving us whatever content we want. And we call that internet. There are different network types, such as local area network, wide area network, or the internet. Huawei provides various network services on the cloud. We will start with the fundamental Huawei Cloud Network service, which is VPC. So, what is a VPC? A VPC is a service that allows you to create isolated networks within the cloud. So in the cloud, you create yourself your own, network. You isolate it, and that is your own network. This is the main purpose. You can create subnets in the VPC you have created. And here in the screen, we see two VPCs, VPC1 and then VPC2. They are both isolated, separate environments. And the VPCs are shown using ECS instances within each. And they're configured in a way that they don't interact directly with each other, and this enhances security. So there is no connection within the VPCs. So essentially, a VPC gives you control over a private section of the cloud and ensures your setups are secure and easy to manage. So what are the advantages? VPC advantages, let's start with flexible configuration. It is user-defined network and can be distributed among ECSs and AZs. It is secure and reliable 100 logical isolation and seamless interconnectivity. We can, connect two VPCs to each other with the VPC peering. If you talk about the architecture, generally a VPC consists of a CRDR block and a routable table and at least one subnet. At this diagram, we see two different VPCs, VPC1 and then VPC2. And in each VPC, you have different subnets. Here is subnet 1, subnet 2, and then in the other VPC as well, there's subnet 1 and subnet 2. So there are like separate areas within the VPC for organizing your resources. We see here in subnet 1, there's ECS instances, and then in the other subnet, there's ECS and RDS, which is relational database service. And, each is grouped by security settings. So each VPC is connected to the internet via internet gateway. Here we see it. And there are additional connections like VPNs and direct connects for secure and private communication between the VPC and other networks or data centers. And network ACLs are in place to manage traffic within the VPC, which ensures only authorized access to and from these resources to the subnets. So essentially, this setup allows for organized, secure, and scalable cloud infrastructure that's separated from other networks because they are separated from each other, and we do the connection between each VPC with VPC peering. And so this is a flexible and interconnected as needed. So if we break down the VPC components real quick, each VPC VPC has its own CRDR block, and here we see it. And CRDR block is a range of IP addresses that are exclusive to that VPC. So this is what gives each VPC its private network space. And like I said, it's shown here as this number. So the first 16 digits, the first 16 show the network, and the rest are for the host. And inside the VPC, we have got subnets, subnet 1 and subnet 2, and which are smaller segments of the VPC. Each subnet has its own slice of the IP address range, as we see here. These subnets help organize and isolate resources within the VPC. So each subnet can have different security groups assigned. We have security group A here, and then security group B and security group A. So these are for the instances inside. They're controlling what traffic can enter and leave the resources like ECS instances or RDS databases. And there's a routing table for directing traffic between internet and different parts of the VPC. So you have got a structured and secure setup that keeps everything orderly and protects it. Here are some of the components we see inside. There's subnet, there's a security group. We can configure security groups for what reaches our instances, resources, and then IP address groups, elastic NIC, network ACLs, routing table, VPC peering connection, virtual IP addresses, and EIP. We have mentioned in the previous slide that a subnet is a unique CRDR block, which is a range of IP addresses within the VPC. And like I said, subnets help organize and isolate resources within the VPC. So you create different subnets within the VPC, so you can arrange, IP addresses based on your desire. And if I talk about Elastic IP, Elastic IP is a service that allows cloud resources to communicate with the internet using static public IP addresses and bandwidth widths. So if you bind an EIP, Elastic IP, to your resource, you can connect to the internet. So if I talk about what a security group is, a security group is essentially a set of firewall rules that control the traffic for your ECS instances. So we see a VPC here, and inside the VPC, they're in a subnet, and inside the subnet, there's a security group. We can configure our inbound and outbound rules to control what comes and goes to our instances inside. So think of it like a filter that decides what kind of communication is allowed in and out of the servers that it applies to. Once you set up a security group, any ECS instance you assign to it will follow these rules. For instance, you might have rules like allow all outbound traffic, but deny all inbound traffic, unless it meets certain conditions. This helps in ensuring that your instances are only accessible in ways you deem safe, and this enhances your overall cloud security. So always configure your security groups based on your desire. So let's touch on what VPPC peering connection is. I already actually kind of mentioned. If we go back to the first, one of the first slides. Sorry. It doesn't show it here, sorry. Here, we see two different VPCs. They're in the same region, and there's a VPC peering connection. So if there are, resources in different VPCs, they cannot connect to each other by default. We have to create a VPC peering connection for them to be able to connect to each other, to talk to each other. So if I go back to the slides, like I said, it's basically a way to connect two VPCs within the same region. So they communicate using private IP addresses. This means your VPCs can talk to each other securely without going through the public internet. So you don't have to open your, resources to the public internet for, resources in different VPCs to talk to each other. You can set up peering between your own VPCs or between your VPC and another account's VPC, but only if they're in the same region. So if they're not in the same region, let's say one VPC is in Singapore and then other VPC is in Cairo, you cannot do it. They have to be in the same region. So this setup uses routing tables to direct the traffic properly between the VPCs. So VPC peering is great for creating a secure network environment across your different cloud resources and keeps everything streamlined and well connected within the same region. And let's talk about network ACLs. They allow us to create rules to control traffic in and out of one or more subnets. So security groups are about what we have inside the subnet. Of your VPC. Here we see subnet 1 and subnet 2, and then network ACL. They are controlled, like what goes inside and out of subnets, they are controlled by network access lists. Let's continue with EIP. We already mentioned what it is. And we said that elastic IP allows cloud resources to communicate with the internet using static public IP addresses and bandwidth widths. EIP is the public static IP name in Huawei Cloud. So they're called elastic IPs. They can be bound to or unbound from ECSs, DMSs, virtual IP addresses, NAT gateways, and load balancers. Here we see an application scenario. An EIP here is binded to a NAT gateway. We see clusters of resources here. And all these resources share one single elastic IP, which gives them access to the internet. And you might ask how these, all of these resources share one single IP. We will learn about it too. Another application scenario, here an EIP is attached to an elastic load balancer. We will also learn about it. And so let's continue with ELB. What is an elastic load balancer? ELB is a network service that automatically distributes the incoming traffic among multiple backend servers according to the listening rules you configured. So here's an ELB, and then there are application servers. Your traffic comes to you, and then let's say one of them is very busy and the other one has no work. Like, we have to figure this out to automatically distribute equal kinds of work. So ELB exactly does this. So here is a user. The user is connecting through the internet, and then the user hits the ELB, and then ELB routes the traffic to various application servers and databases. This setup boosts the application's performance and keeps things running smoothly by avoiding single points of failure. So, it protects your system from, crashing, or you don't have to underutilize your servers if your ELB works with auto-scaling. So let's talk about ELB advantages. First off, it has got robust performance, handles up to 100 million connections at once. High availability with cluster deployment and real-time switch hour is another plus. And it's scalable, it distributes traffic based on application needs and works smoothly with other services. Flexible forwarding supports multiple policies to meet different needs. The boundless load balancing is cool too, and balancing resources across on-cloud and off-cloud setups. So lastly, it's easy to use, quick to deploy, and offers varied scheduling options, makes everything run smoother and more efficiently. And let's break down the ELB architecture simply. We see the ELB here and load balancers, listeners, and backend servers. An ELB consists of 3 components. The load balancer first, the second is listener, and the third is backend servers. So if you think about it like a traffic cop, it manages where requests go based on the rules you set. A listener uses protocols and ports to monitor incoming requests from clients and forwards these requests to the associated backend server based on the defined listening rules. And as you can understand, this setup helps ensure your application runs smoothly without any server getting too overwhelmed. So let's, one by one talk about each of these components. First, we will start with load balancer, then we will continue with listener, then we will continue with backend server. A load balancer is a network service. It distributes incoming traffic across multiple backend servers, like I mentioned. Load balancers can work both in public and private clouds. We can enable public access to the internet with a gateway, like we see here. And as I mentioned, a listener listens on requests from clients and forwards these requests to the backend servers based on the way you have configured the settings. So I mentioned the first 2 components of an ELB, which were load balancer and listener. Here's the other component, backend server group. It basically represents a group of cloud servers that have the same features. When you add a listener, you select the load balancing algorithm and you create a backend server group. The incoming traffic is routed to the corresponding backend server group based on the listener's configuration. And we also have ELB health check. It literally checks the health status of backend servers by sending requests to the associated servers. In this way, it detects when there is an unhealthy server and ensures that traffic is only distributed to the healthy servers. So it does HTTP GET requests and then does HTTP health check. Based on this, you understand whether your servers are healthy or not. So here's the configuration process. First, you create a load balancer, and then you click by Elastic Load Balancer, select the load balancer type, you configure the network, then you locate the created load balancer, you configure protocol and port. This way you add a listener, and then you add a backend server group. You select a load balancing algorithm, and then you configure a health check, if you don't mind me. So let's talk about an application scenario. For busy apps like a big web portal or mobile app store, the ELB helps spread incoming traffic across several backend servers. So this keeps everything running smoothly. Plus, it uses sticky sessions. If you ask what is sticky sessions, they ensure that requests from one client are always forwarded to the same backend client. So if I continue, I will continue with VPN, virtual private networks. We all may have heard of VPNs. So what does VPN do? VPN allows you to establish encrypted internet-based communication between the on-premises data center and the VPC. So it creates a secure, remote access to your resources. And what are the advantages of VPN? It is highly secure, it provides high availability, is cost effective, and very easy to use. And VPN connection is an encrypted connection between VPN gateway and remote gateway. It ensures communication between VPC and the data center, as we see here, on-premises data center and the VPC on cloud. The gateway links your cloud VPC to your own data center securely, allows encrypted communication. This is how you set up a secure bridge between your cloud resources and your local systems very quickly. So here's an application scenario. VPN lets you connect VPCs across different regions. See, Huawei Cloud Region A, Huawei Cloud Region B, to keep services in those areas linked up. Here's the other service, Net Gateway. The Net Gateway lets servers in a VPC use a single internet-facing IP address. In one of the previous slides, I said that there's a single EIP like this one. There were, several resources inside, but they are using a single IP. So how does all of these, resources reach the internet, and then they send their requests and their requests come back to them? How is the way found? This is what the Net Gateway does. The NET is known as Network Address Translation. Here we see SNET and then DNET. With SNET, our resources use a single EIP to reach the internet. So when they're, sending something, they're using a single EIP. And then DNET does the exact opposite work. Traffic from the internet comes to a single EIP, and DNET does the destination network translation. Net Gateway offers several benefits. They handle loads efficiently, enhance security by shielding individual IPs. Your IP doesn't have to, we see resources here. They share a single EIP. Their private IPs are not shown to the internet because network address translation, Net Gateway, literally, keeps it private and then, translates whatever private IP it is and, shows the way. So it allows flexible configurations across different areas and is user-friendly, helps in reducing costs by sharing a single IP and bandwidth resources across multiple instances in the VPC. So let's talk more about SNET and DNET. Like I said, secure network address translation, SNET. During NET, only source address in packets is translated. So this NET mode applies to the scenario where private network users access the public network. And in destination network address translation, during NET, only the destination address and port number in packets are translated. DNET applies to the scenario where public network users access private network services. So here's an application scenario, and let me break it down to you. In this diagram, we have ECSs and BMSs in a VPC that need to access the public network. Instead of exposing their IPs directly, we use a NET gateway. This gateway uses something called SNET rules. These rules allow multiple ECSs and BMSs to share one single IP. Resources, one single EIP resource, and it prevents the resource's IP addresses from being exposed to the public network. So basically, it helps manage a large number of requests by assigning different connection numbers. It's efficient and keeps the ECS IPs hidden from the public network. You can even create multiple SNET rules based on your service plan to optimize the use of EIP resources. It's simple, right? And we may continue with other services by Huawei Cloud. What is a DNS? Our domain name service is highly available and scalable authoritative DNS service that translates the domain names like, for example, let's say example.com into the IP address. We know that, servers have IP addresses and the internet is literally just a bunch of servers. So they all have IP addresses, and then their IP addresses, we know them as domains like Huawei.com, it actually is a number. Here, example IP, for example, example.com IP address is like 192.1.2.3, and DNS reliably directs end users to the application. So DNS provides domain name resolution for various scenarios, including resolution for public domain names, resolution for private domain names, reverse resolution, and intelligent resolution. So I will talk about these lastly. What are DC and CC in Huawei Cloud? DC, known as Direct Connect. It connects your on-premises data center to Huawei Cloud. So you have an on-premises data center, and then you have Huawei Cloud. You have to connect them. How do you connect them? With direct connection. And what about Cloud Connect? Cloud Connect connects VPC in different regions together. I said if the VPC is on the same region, how do you connect them? With VPC peering. But if the VPCs are in different regions, how do you connect them? With Cloud Connect. In this way, those instances in different regions, in different region VPCs can communicate over a private network as if they were in the same network. So you see here, we have a on-premises data center here. And with Direct Connect, we connect it to a VPC in South China. But if there are VPCs in different regions, you have to connect them with Cloud Connect. Now, I will continue with all of our favorite Kahoot. So let's have the first round of questions. I will share 1 second. Here is our QR code and our game pin. I will wait a few minutes for you all to register. If you are on your desktop, you can, go to Kahoot, and then you can put the game pin to join our Kahoot session. I see the last week's winner, Necati Tetik. Welcome. We will continue our session with a hands-on lab. But first, I would like to introduce what KooLabs is to you. KooLabs is Huawei Cloud's official lab platform, where lab environments can be launched in a single click. Following the lab guide, developers can quickly get started with Huawei Cloud services and implement, debug, and verify them on cloud. So let's share this link with you. 1 second. Sorry, 1 second. Here we see KooLabs, what KooLabs is. We can click, you have to first register, and then you can click on popular services, exercises, and when you click, you get to, follow a guide, and then you get to see there's a network services practice, and then deploying an enterprise practice, and then compute services practice. And let's say if you clicked on this, and then it shows you a lab environment, a guide, you get to experience Huawei Cloud and the services for free, and you get to learn. It's actually very educational. So today I will continue with hands-on lab. I will create 2 different VPCs, and then inside the VPCs I will put subnets and then resources. The VPCs will be in the same region. I will connect them with VPC peering, so we will apply what we have learned in the past weeks, and then I will create an ELB to distribute the traffic that comes to our resources. So bear with me and hang with me. At the end of our lab session, I will hold another Kahoot. So if you give me 1 second, I will open my Huawei Cloud account. Okay, thank you for telling me that that I was muted. I was saying that if I go back, I'm sorry for this. I was saying that we have to pick our region based on where we are, because this is important for latency. We learned what latency is. Latency is the amount of time that is passed for you to reach, and this is very important. You have to pick the closest region. So let's create a VPC in Cairo together. I am in Cairo, that's why I created in Cairo. So let's name our VPC VPC1. And like I said, I will create 2 VPCs. In VPC1, we will have 2 subnets. So subnet 1. And this is a good warning. The subnet's CRDR block cannot be modified after it is created. I added different subnets. They cannot hear. Can you hear me? I'm not muted. Okay, if you can hear, I will continue. Okay. So here I add the second subnet. One second. Okay, you see the screen? All good? So here I created I'm creating a VPC in Cairo. I will create two VPCs in total, and in VPC 1 I create subnet 1 and then subnet 2. So each subnet available IP address is 251. The first 16 are showing the network address, and the last 8 bits are for the host. So if I change it to be less, the first 29 are for host, the network, and the last 3 are for host. So IP address availability is less. I will change it to the default, and I will create it now. I will create my second VPC in Cairo region. I'll create it now. See, our subnets, our VPCs are created. VPC 1 has 2 subnets, and then VPC 2 has 1. So I go and I will create now ECS instances. I talked about what ECS is. ECS is our Elastic Cloud server. It is the virtual machine in Huawei Cloud. So I'm in Cairo region. I am buying it in Cairo region, but I can change if I want. If you don't find the specific server that you want to use, you can find it in other regions. Some other regions have more options. In Cairo region, we have only one AZ. So I will select pay-per-use. And by the way, to be able to do this, you have to register to Huawei Cloud. And I will show you, and I will share you the link actually to register to Huawei Cloud. I will pick the least powerful compute resource. Here we see the ECS specifications. I picked first pay-per-use, and then I pick region. We learned about these. In regions, there are availability zones, AZs. And the instance size that I want to choose, I choose it by type. It has one virtual CPU and memory, and then it shows what kind of CPU it uses. And then here I pick a public image. I can also pick a private image or a shared image or marketplace image, but I pick a public image. I pick the operating system, CentOS. And then I pick the disk type. I will choose it as general purpose SSD. And in network, I am using, by the way, we learned about EVS disks. So if I want to add disk, I can add disk now, add data disk now, or I can attach a data disk later. So here I pick VPC1. And it will be in subnet 1. The security group is default. I pick the security default group, but I can also create a security group by myself to, limit the inbound and outbound rules or extend them. And I will say EIP is not required, but I will attach the EIP later. For other purposes, the ECS name should be ECS VPC. VPC1, ECS, subnet 1, ECS. I will log in. Here, I wrote down the name of my ECS, and then my login mode is with password. But if I want, I can actually create a key pair. So the key pair is literally you just, do it with SSH, and your key pair, you save it, and then you don't have to use a password. You just, do SSH connection. But you have to allow the inbound rule port 22 because SSH uses that port. So let's continue. On the side of the screen, we see the summary of our configurations. Let's go back to the ECS list and create one more ECS in the same VPC, but in different subnets. So pay-per-use, Cairo region, and then I pick general computing small. Then I pick the operating system CentOS. For system disk, I pick general purpose SSD and then system disk 40 gigabytes. And network, I pick VPC1. And like I said, the subnet is subnet 2. And I say EIP is not required. The name is VPC1, subnet 2, ECS. I put a password. Because I am using an enterprise account, I pick my name. But when you create an individual account, you won't see enterprise project if you have not created an enterprise project. I agree, created. Oh, I accidentally picked subnet 1. I need to change it. So I will have to delete the ECS. My bad, I go back to ECS list. Well, now you will see how you can delete your ECS. We're waiting for it to be created. Okay, and now here you click on more, and then the settings come. You can say by same ECS, you can say stop, restart, reset password, modify specifications, delete, manage image. You can change operating system, reinstall it, or create an image from it. So here there are create server backup, there's create disk backup, add disk, expand disk, and manage network. I'll just delete it. I will buy it again, and then I will just, configure the subnet setting. Here we go. Why doesn't it let me? It doesn't let me pick properly. Very important. Very interesting bug here. Literally doesn't let me pick. There's a problem that it doesn't let me select subnet 2. It's okay. We can just, continue with the same subnet. Yes, subnet 2 is in VPC 1. As you see here, subnet 1 and subnet 2, they're inside VPC 1. There's a minor inconvenience. I will report it to the team. I don't know what's happening. One second. All right. So I'm sorry that this is happening. Maybe there's a bit of a problem. Yeah, the problem is with the system, it doesn't let us create. So maybe, and the time is almost up. Maybe I do this in the next, I report this problem to the team, and then I do this lab in the next week, but I will continue with Kahoot. I'm really sorry that this happened. So I will please get ready for Kahoot. So here is our. Oh, sorry. A second, I'll share the screen again. Here. So which Huawei Cloud service enables communication between VPCs within the same region? Congratulations to Hakan Arslan. Congratulations to all. So for you to be able to register to Huawei Cloud, please go to huaweicloud.com, international and US. And to follow us on Instagram, please go to HDGNA. And for Facebook, this is our address, HDG Northern Africa. And to join our WhatsApp group, please scan this QR code. So thank you all for joining us today. And I'm sorry for the minor inconvenience with the lab, but I will report it to the team and I will continue with the lab next week. So thank you all. So I hope you're able to scan. And if you are, see you next week. Take care. And if you have any more questions, please write it to our YouTube. Thank you. And if you couldn't write it on YouTube, please text us on our WhatsApp group. See you next week, guys.